Here is a magnet. Magnets have sides, a north side and a south side. If I take a second magnet and I approach the first magnet's north side with the second magnet's south side, they attract. If I approach the first magnet's north side with the second magnet's north side, they repel. It'll happen on the bottom too. Whoop. Versus. Ah! Okay, now if I approach the first magnet with the second magnet sideways, if I do it like this, they will repel. And if I turn it upside down and do it like this, they will attract. Now, that means something interesting, because watch this. Let's say I take this first magnet and I break it in half this way. Now I'm going to have two new magnets, and they will attract each other. The top half of the broken off south side will become a north side. The bottom half of the broken off north side will become a south side, and they will attract. Now here, check this out. If I break it the other way, if I break it in half this way, it will not do something like that. What I'll get is two new magnets that both have the same sided orientation, which means they will immediately repel each other. So one thing that means is that for every magnet in its normal state, internally, it's actually repelling itself this way, and it's attracting itself this way. Interesting thing to know about what's going on inside any magnet. But there's something even crazier that this all means, which is a dramatic correction to science actually. Scientists got the impression that magnets have something called field lines inside of them because they took some iron ferrites, which are little bits of iron, which is magnetic, but it's not, they aren't magnets. It means either side of a magnet can attract them. As soon as a magnet does that, though, those little bits will become magnetized. So if I take a little bit of ferrite and it's magnetic, but it's not magnetized yet, here's one blown up, and I start bringing it towards this magnet, what's going to happen is as it approaches it, and I'm blowing it up a little more, the bottom side of it, approaching this north side, is going to magnetize south, and its top side will magnetize north. And this will be attracted, and it'll stick to it, and this bit of ferrite will now be magnetized. So what that means is that as I bring a whole bunch of little ferrites towards a magnet, all of them will do that same thing. And guess what? They're going to repel each other sideways. And you get the distinct little spiked pattern. As I bring more ferrites to it, they will stack against each other, all forming, like in this case, it would be little south-north stacked orientations over and over again. But these little stacks will all be repelling each other sideways because the poles match across them. See it? And so you get the impression that magnets have something that scientists called a long time ago field lines, meaning they thought that, oh, a magnet, it has lines of magnetic force because of how when you take these ferrites, it looks like this. But actually, magnets have uniform north and south fields. They don't have field lines at all. They have magnetic fields that are just uniform. Get it? Isn't that interesting? That's a major correction to science. And I'm Josh Saban, and I discovered that just by playing around with magnets a lot and ferrites and breaking them here and there too. Enjoy.